Masai's not here either. Joanna, Kevin, Ehong, Christina, Johnny, Luis, D'Anthea, Brian.
Yeah.
Hello.
Cheer on.
Did it work, Eli? Okay, thank you.
Want to cheer?
What do you, Brian, which one do you need? You got it? Okay, so Lazaro's not here, so so literally just set that equal to 0 and
Chilies. You get chilies.
Those 5, and then
don't worry about it, Leo. Just make it and let's go.
Oh, you want me to give it to me?
Well, yes, but then X squared is 1.
After. Just do that. But I can do that to chili.
What are you doing? What's happening? A few more seconds. You take the square to both sides, you always get your answer plus 1. Hey, Leo, you got your marble card?
that's for white.
Good. Horizontal, yeah, bigger on bottom, bigger on top, or exponents are the same. I know, but I still need you here on time. You gotta get your Thank you.
I didn't want to see. Martin doesn't have.
Martin doesn't have a pass. Martin doesn't have a pass.
Y'all keep working. Lazaro, I think you your problem set. They just started coming. Lazaro, okay. There's actually a ton of them in this table because all of them are gone. Do you want to use it over here? I think it'd be easier. Okay, y'all, you got a few more extra seconds because I'm going to change the attendance for the people that just came in. Okay, voices up, eyes up here so we can get started. Thank you very much. Okay, hopefully y'all can see this. I couldn't get the thing to work, so I'm having to like dot cam my PowerPoint, which is super weird, but stick with me. It's also Friday, so today is raffle day, and you will be getting one of 3 lovely prizes behind the colored folders, so stay tuned for that. Let's go ahead and get started. Really quick recap of vertical and horizontal and domain, because today we are going on to 2 new rules, so we just have more to remember, so we want to make sure we feel really good about these. So, before we jump into these problems specifically, who can just summarize for me for a ticket what is our rule for finding the vertical before we start? What is our rule for the vertical? D'Anthea? What x value will make our denominator equal 0? And D'Anthea, for this one, really quick, can you see what that would be? -2. X equals -2 would be the equation of our vertical asymptote. Okay? Now let's talk horizontal. If we're in the land of horizontal, what are we checking for our horizontal asymptotes to figure out those? Christina? Pretty much, yeah. If the exponents are the same, or if they're not the same, whether it's bigger on the bottom or bigger on the top. Okay? So let's take a look at this one. In this case, are exponents the same?
Yes.
Yes. So if our exponents are the same, we're going to divide the coefficients. That's what I say, each DC. Exponents are the same. Divide coefficients. So we have 1 divided by 1 would be y equals 1. Oops, no, I'm writing it. I should do that. Okay. And last, your domain would go from, I keep having to change attendance. Our domain would just have everything except for the -2. So Kennedy, tell us what it would be.
It would be parentheses, negative infinity, -2, parentheses, union, parentheses, -2, positive infinity.
Boom. Cool? Okay. For the next one, so check off what you got for that. For the next one, the bottom equal to 0 for your vertical is going to be a little bit more challenging. So I recommend, if you can't see it, literally set the bottom equal to 0 and see what you get. So everyone, if you haven't already, set 5x squared minus 5 equal to 0. Then add over the 5. You can be writing this if you haven't already done this one. Add over the 5. And you'll have 5x squared equals 5, right? Then we're going to divide by 5. And x squared equals what? 1. And last, to find x and get rid of the square, what are we going to do? Square root. However, I think a lot of people then wrote probably just 1, which is correct. However, when I take the square root of both sides, it's 1 and -1, plus or minus 1. There's actually 2 values that we could square to get 1. 1 squared is 1, and -1 squared is 1. So we have x equals 1 and x equals -1 for that one. Okay? Alright. Then, horizontal. Raise your hand if you got it. Ehong, what did you get?
Y equals 0.
Not quite. So that would be bigger on bottom, which the 5 is bigger on the bottom, but we're looking at the exponents.
Y equals 1, 2.
Good, y equals 1. Cool. Dividing their coefficients, 1 over 5. Happy? Okay. And then your domain needs to throw out -1 and 1, so I'll just show you that one for the sake of time. Check it if you got it, and we'll move on if there's no questions. Okay? Alright, so that is Tuesday's lesson, and what hopefully you got a chance to practice yesterday if I saw you and you're working on your problem set. Keep working on that this weekend. Today, we're going to talk about 2 special cases where a graph might also have something we call a slant asymptote, or could have a hole in our graph. Okay? Before we get started, just remember your problem set 3 is due on Monday. So please reach out to me over the weekend via email if you have any questions. I also mentioned, and I think for the sake of time, it took a little longer than I expected to get started with people coming in. So I was going to say calculator check starts today because that was what we discussed on Tuesday. However, I'm going to keep us moving for the sake of time and not write down everyone that doesn't have one. So starting next week, random checks, probably most days of the week, to make sure you have it. Remember if you don't, so make sure you have it, okay? And then, just so you know, you have your second quiz of Unit 2 on Wednesday, which is basically like a mini unit test, so it can cover anything on Unit 2. So you should be looking at problem set 1, 2, and 3, and reviewing your last quiz to make sure you still got all that stuff, all the polynomial stuff, okay? And then also looking at this new asymptote stuff to add on for this new part of the unit, okay? Alright, let's talk about holes and slant asymptotes. Before we jump in, I think this is right below at the bottom, right? Yeah? Okay, cool. We, for the sake of time, are actually not going to find the intercepts, so just change the direction slightly for me, because I want to make sure we can keep moving kind of quickly. So we're going to focus today just on the asymptotes. So it says determine any asymptotes, just like we did in the do first, okay? And then we're going to graph the function on our calculator to kind of check our work and make sure we know how to find the domain and the range. And then we're going to see if this one looks any different. And it is going to, and that's going to kind of lead us to talk about some of the new stuff. So let's knock out the stuff we already know kind of quick together, since you did this on your own in the do first. So Melanie, what do you want to do first, vertical or horizontal asymptotes?
Vertical.
Let's knock out the vertical. Okay, vertical asymptotes. I'm like, oh, I need to make the denominator equal to 0, but it's a quadratic. How do I find out where that's equal to 0? What I do? Okay, go ahead, take like a minute and factor it using your box method so we can find our zeros of the bottom.
And nothing happened, y'all. It was just this. No, I didn't. It was here for my nose. So mean.
Alright, and what do you get for your two factors? Okay, so for your roots, for her roots, she ended up getting that for your factors. What do you get for these factors right here? Okay, x plus 4, x minus 3. So that means then she said her roots, or where the denominator would be 0, which is our horizontal asymptotes, are at x equals 3 and x equals negative 4. Okay? So check that off if you have it. And then you also have your participation thing. I'll stamp it. Cool. All right. For our horizontal, I didn't do my box, y'all can just check. For my horizontal asymptotes, are we... Let's go with Diego. Bigger on bottom, bigger on top, or exponents are the same? Bigger on top. Cubed on the top, squared on the bottom. If it's bigger on top, it's none. If you use our memory trick, you're like Melanie up there. BOTN, none. Alright. So for our domain, we would say we're starting at negative infinity. We're going along. Where's the first time we hit a vertical asymptote? Negative 4. Stop. Then, pick up from negative 4. We're going along. When's the next time we hit another one?
3.
Stop. And then, from 3, we don't have any others, so it looks like this. Okay? Okay. Do you have your presentation thing? For our range, I had someone ask me a good question yesterday or the day before or something about the range, because they noticed we'd been doing domain a lot, and they were like, will I ever have to do the range? And I said, well, maybe. So let's talk about the range. If you are talking about range, domain, we were looking at our x values. So for range, we're going to be looking at what? Y. So we're going to do the same process. We can start at negative infinity, but that's now thinking of like the bottom, and you're thinking, am I ever going to hit a y value, which is a horizontal asymptote that I have to stop at? You start at negative infinity, are we ever going to have to stop at any values? So we're going to go all the way up to positive infinity. That would be all real numbers for your range. Okay? Alright, so we go ahead. We're going to graph it on our calculator to move you along. And for those of you that maybe don't have your calculator today, tisk. It ends up looking something like this. And if you're following along and you want to graph it, you might need to zoom out. Some people this morning were like, I only see the middle part. So you might need to zoom out some to be able to see the entire graph. But you can take a look. This confirms what we were thinking. Let's look, our vertical asymptote, we should have 1 at 3. If I look over here between 2 and 4, that makes sense for our vertical asymptote to be there, right? And then where should our other one be? -4, 2, 4, they're counting by 2's in my graph, so that would be right here, and that's where that other little imaginary line is. So that makes sense. We feel good about our answer. Okay? We don't see any horizontal asymptotes, but what you're going to start to notice today is there is a special case when sometimes our graph looks like there's almost like this imaginary, also slanted line. Like a diagonal line, it doesn't level off flat, horizontal, but you can almost kind of picture this like slanted line that our graph is going along right there. And for different purposes, it might be helpful for us to know the equation of that slanted line as well, okay? So that's what we're going to talk about today is 1, when does that happen? And 2, then how do we find the equation of that line, okay? So let's talk about slant asymptotes now on the top of the next page. Take a look. An oblique asymptote is another word for what we call also a slant asymptote. So you can write down there in your notes if you like both of those. If I say one or the other, that's going to be like a synonym. It's going to mean the same thing. And now we're going to write down like when that's going to happen. But if you want to add on over here that it's also could be called a slant asymptote, you'll see both and then you'll be familiar with both. Okay, so this slanted line or oblique asymptote happens when, special case, the degree of the numerator is exactly 1 more than the degree of your denominator on the bottom. When the degree of the numerator is exactly 1 more than the degree of your denominator. So let's break that down and make sure we know what that means. I'll give you a second to write first. Okay, raise your hand if you can tell me what I mean by degree. What am I talking about when I say my degree? The exponent, right? The highest exponent of the top and the bottom. This says that the highest exponent of the top has to be exactly 1 more than the highest exponent of the bottom. Okay, so if we look back at this last example really quick, what is our degree on top? Cubed, like to the 3rd power. What's our degree on the bottom? Squared. 3 is exactly 1 more than 2, right? The degree is 1 higher on the top. Whenever that happens, that's when we're going to have this behavior in our graph, and we're going to have a slant or an oblique asymptote, okay? So it's technically always when we're bigger on top, right? So we shouldn't have any horizontal asymptotes. Then, if that happens, if you ever see none for your horizontal asymptote, you're like, oh, it's bigger on top. Check and see, is it bigger on top by 1? Because if it is, you're going to need to write your slant asymptotes, okay? So let's go ahead and take a look now at how we would find that. Ehon, do I owe you 2 from earlier too? Or I gave you that one already? I just forget. Oh, the stamp. I'll be back with your stamp. Where's the stamp? There it is. Okay, so look at this example. Really quickly, I said it already a couple of times, but can I get someone to summarize one more time using this example? How do I know this example has an oblique asymptote using what we just said about oblique asymptotes? Kevin?
The exponent on the top is x2, which is one number higher than the one on the bottom.
Yep, the one on the bottom is to the 1st power, the one on the top 2nd power, so it's 1 more, okay? So when that happens, we see here there's also this oblique slanted asymptote, okay? The question now becomes, how do I figure out what it is? We know when it happens. Now how do I figure out what my slant or my oblique asymptote is given my rational function? So, instead of me just telling you, what I'm going to have y'all do is read this paragraph. We're going to practice our math reading skills. Ooh, that's scary. And as we read, I want y'all to try to come up with at least one. I want you to like right here and kind of like annotate on your page in your own words, not just repeating the paragraph. I don't want you to write the paragraph again. I want you to write in your own words one thing for you to pull out of this paragraph that you feel like might be important. And kind of from our observations, let's see if you guys can kind of like break down how we're going to find it, okay? So it doesn't mean you have to understand this paragraph perfectly, so don't freak out. I want you to read it and come up with one thing to share with us. I'm going to give you 2 minutes of silent reading time. And after about a minute, I'll give you a time reminder, and you can try to start writing down something you notice. Go ahead and read about slant asymptotes. Okay, so it's been about a minute. I see some people that underline things. Give it another minute, and if you need to reread, you can, but then I need you to jot down something you noticed or read about oblique or slant asymptotes that you could share from the paragraphs. Make sure everyone write down something. What does all this stuff mean? Write down something you noticed. 30 seconds. Okay, let's take a look and see what we think of this is important. I mean, it all has something to like kind of add, but we're specifically going to try to focus on, and it's okay if what you wrote didn't focus on this, but we're going to specifically try to focus on, okay, how do I find the function for the oblique asymptote or the equation for the oblique asymptote, okay? So taking a look at this paragraph, let's talk about a few things we noticed. I'm just going to pick someone to share anything, no wrong answer that they read without reading it back to us. Luis, without like reading a section of it, can you just share something you read here?
So
Not sure? Okay, I'll come back to you. This is kind of weird, like, I know a lot of times I like summarize it, so it's kind of hard to like read it and then feel like you have an answer, so it's okay. Anything you got from it, I'm going to try someone else. Johnny, something you noticed? What did you write? Y'all can do it. Huh? Yes, Eli, try it out. I'm gonna do this a lot more often. I like went to my little content day back. Y'all remember? Y'all had that Friday off. I went to school. Y'all remember that? And we talked about reading math and how to like make sure y'all can kind of like internalize. So I'm gonna try to build that on as a skill. Beginning of the school year, I kind of like did that for you. I'd be like, this is what that says. But I'm gonna try to get y'all to start breaking it down. So Eli, you try it out.
So basically, I guess this fraction right there, this fraction is not.
Okay.
The bottom one has to be greater than 0, or like squared.
Cool. Perfect. So one thing that you noticed is that it said something about the degree of the bottom one has to be bigger than 0, because like technically if it's 0 or -1, we get all these weird cases. If it's 0, like the x actually isn't even there. So we're talking about, we definitely are looking at rational functions where we've got at least a power of 1 or higher, like x squared or x or something like that, okay? So that's kind of just like a leading in, clarifying part about what has to be true about our function before we can even do this. So let's dig in a little bit deeper though. Did anyone notice anything about what it said about how we actually will find the oblique asymptote? So if all that stuff works, it talks about a bunch of stuff, how do we actually find the oblique asymptote? Anyone pick up on that? Melanie, what do you get? Divide. The key word here is it says it is the quotient polynomial resulting from the division. The key idea here is that we need to divide, good job y'all, to find out what our oblique asymptote would be. So if you didn't write anything, because you were like, that's fine, but I want you to go ahead and steal Melanie's answer right now. Like one thing you could have written, it didn't even have to be a sentence, is you could have pulled out something about division from that. Okay, cool? Alright, so we could divide. So right here, they gave you this one. They say the oblique asymptote, I'll write it a little bit bigger, is x minus 1. Okay, so we know that's the answer, but let's walk through how to actually get it and see that that's our answer for our oblique asymptote. Okay, so we're going to divide a of x by b of x, the top divided by the bottom. In our example, what's the top? X squared, and we're going to divide it by the bottom, which is what? X plus 1. So this, you might be like, what? How do I divide? Remember, we learned something. Synthetic division. It's a way to divide polynomials, okay? We'll get to the coefficients in a second, but if we're dividing by x plus 1, Lazaro, do you remember what we would write in here for dividing by x plus 1? -1. We put our root, or our 0 over here, right? Okay? Now, let's talk about the coefficients, because this one's, and you all can write down the synthetic division. Use this as an example to add on to your notes, and then we'll do the next one together. If this is our polynomial, it looks kind of weird. We're used to seeing things that look like this, right? Maybe something that's like that, and you would write 2.5.7, right? Okay, so let's talk about what happens if I only have the x squared. What's in front of the x squared? 1. But I can't just write that because I still need to write all 3 terms. I should have 3 terms if this is squared. So what do I have to put? I have 0 x's, like there's none of them, right? And then I have 0 as my constant term. It's almost like this is equivalent to x squared, right? I don't have any x's, I don't have a constant term, and I have 1 x squared. So we're going to write 1, 0, 0. This is kind of a weird case, so just kind of stick with me, okay? Alright, let's go ahead and do our synthetic. We know the drill. We bring down the first one. Go ahead and start multiplying and adding for me. Here we go. Should see people doing their synthetic. 1 times -1. 0 plus -1 is -1. -1 times -1 becomes a +1. 0 plus 1 is 1. Okay? So we end up with our synthetic. So this is the quotient. Like Melanie said, we want to divide because it says that the quotient polynomial is the function for the oblique asymptote. Notice we also get a remainder. What's our remainder? 1. But if you look closely at their little explain section right here, the function from the oblique asymptote only comes from the quotient. This r of x, the little remainder, actually isn't going to be a part of our oblique asymptote. So the only part we care about is this part right here. Okay, let's write that as a quotient polynomial. So if it was x squared before, this would now become 1 what? 1x minus 1. 1x minus 1, which I could write as just x minus 1, right? So our equation is, of our asymptote, y equals x minus 1. And hey, look, that's exactly what they had, right? Y equals x minus 1 is what they said the equation of that oblique asymptote is. Okay? So when do we have an oblique asymptote? When the numerator is bigger by 1. How do we find it? We're going to do synthetic division to divide the top polynomial by the bottom. Okay? That's kind of a summary of this. So if you look at my poster, this little n equals n plus 1 means the n power on the top has to be 1 bigger than m plus 1, okay? And then I wrote right here, equation of the slant line is the quotient. So you have to divide to find the slant line. Cool? Alright, let's try it. Okay, this problem right here, take a look. I want y'all to go ahead and try it with your neighbors. You're going to be finding not only just the asymptotes we've done before, but now notice there's like a section that says oblique asymptote, which means you need to try your synthetic division to find that one as well, okay? Try it out. I'll be walking around to help and give out tickets to people working hard.
Okay.
Good job, Johnny. I know, I'm coming. Good, got that one. Very nice. Got our vertical. Now for our oblique. Let's check and see if it has one. Is the top bigger by 1? Yes. So go ahead and set up your synthetic division to find the oblique asymptote. You're dividing by x plus 4. So we would put what? Yeah. It's essentially going to be your vertical asymptote. It's going to be there, right? Okay, let me see. So first, let's go vertical. That's what it wants first, VA. The vertical asymptote is where, yeah, but technically X or Y. Okay, there you go. Okay, and then now for your oblique. I love it. Martin's got it set up. We're going to have to do synthetic division to find that. You got it as well. Then you got your domain. If you're done, you can graph it on your calculator and see what it looks like. Okay.
What about the intercepts?
You can, yeah. You guys can, for the sake of time, if you want to skip the intercepts again, you can. And if you finish, you can graph it on your calculator to look at your asymptotes and see if it follows what you said. Yeah, you can skip that. You just go to the domain and then graph it. Oh, you got it. This is correct.
This is an imaginary 3.
Okay, so this is going to be right here. So the remainder doesn't matter. I just need to get numbers that were exactly the same. But it comes from these ones, except for the remainder. So see how this function for the oblique asymptote comes from 2 of x. 2x means our quotient. This is our quotient and this is our remainder. It comes from these 2. Since it was x squared, and we divide it, it goes down by 1. Now it's 1 x minus 1.
You're starting to trigger back.
How we do? We okay? Very good. Liz, you got it? You feel okay? With the division? What?
First you have the oblique asymptote.
Check this. You're not multiplying these, you add these. Oh, you don't.
Okay.
So for intercepts, to find your place that it would call the y-axis, that would be where x is 0. So put in 0 to your equation and see where okay. And then you got do that. Okay, how are we doing with our dividing? We're good? When after Joanna goes. So you like going when Joanna joins? I know. Fucking instinct. How'd we do? We feel okay? We ended up with the same thing. So far, so good. You don't have to do that, but you can if you really want to. And then you can find the difference. Okay, we're gonna check and move on. I went around and saw most people, so I'm just gonna put up answers for people that maybe didn't get a chance to get checked off by me, and you can self-check them yourself. And if you look at our picture here, I like to look at the graph to make sure our answer makes sense. I should have a vertical asymptote at -4. 1, 2, 3, 4. Here's -4. Does that look correct? Yeah. Okay, then I'm like, okay, I now know I should have a slant asymptote because I'm looking at my graph and it looks like there's this diagonal line like right here. And if you really think about things that you've learned about lines, I don't know if y'all remember mx plus b,
Yeah.
right? That means your slope is 1 and your y-intercept should be -1. And it makes sense for this line to go through -1 and go over 1, up 1, over 1, up 1. It looks like it's aligned with like the line that I had right there. So, I mean, you don't have to check all of that, but it's just kind of cool to see that the line we came up with makes sense for the graph we see. Cool? Okay. I'm going to, for now, skip this example. We'll come back if we have time, but I want to make sure that in our last bit of class we get on to when we have a hole in our graph. That was slant asymptotes. We should be okay. If not, call me over and we can talk. Okay, let's go on to this example that's talking about this function, x squared minus 4 over x squared minus 2x minus 8. It asks us for, putting everything together, asymptotes, holes, we're going to talk about that, and then one more time, let's just for the sake of time focus on those, we're going to cross off our intercepts. Okay, asymptotes and holes. For asymptotes now, we need to check horizontal, vertical, and now we want to check and make sure we don't have any slant or oblique. So let's kind of run through this together. One more time, let's see, Nen, you get to pick this time. What do you want to start with? Horizontal, vertical, what do you want to do first? Vertical. She says let's do the vertical first. Same as Melanie. Okay, so we're going to find our vertical, which is where the bottom is 0. I'm going to make this a little easier for you and factor it to speed us up. It's going to be x minus 4x plus 2. So let's go with Martin. What would we get as our 2 vertical asymptotes? -2 and +4, interesting, okay. And then let's move on to our horizontal. Jamie Lynn, over to you. Bigger on bottom, top, or are they the same?
They're the same.
They're the same.
1. Y equals 1.
Good, y equals 1, thanks for changing that. So 1 divided by 1, y equals 1 is our horizontal. Okay, we write all those things down. We now need to check our slant asymptote, which, let's take a look. When did we say a slant asymptote would occur? Good, yeah.
He's shown?
He's like, let's move on. Okay, so is the top bigger by 1? No. So you're like, I don't have any. If you really want to write down, you can say none if you're being really thorough and you want to say that there's none. If there's none, you don't have to list it, but it's kind of nice to just make sure you check all of them, right? Okay. So I kind of lied to you.
That's a sin.
Nice. But kind of. It's one of those lies where I just left something out because it was going to be too much. I left out this thing about holes. So if you were to go and graph this, something funky is going to happen, and it's because actually I kind of lied. Vertical asymptotes. One of those is actually not going to be a vertical asymptote. The examples we've seen so far have actually had vertical asymptotes where we wrote them. This is the first one that something like this is happening. But let me show you the graph of this really quickly. Here's our graph. Take a look at your graph and take a look at your vertical asymptotes. Raise your hand if you can tell me what you notice or what seems to be wrong about our graph based off of our vertical asymptotes that we said we should have. Kennedy, what do you notice?
There's no
Yeah, we should have here, I feel good about 4, right? But at -2, we wrote down that that's a vertical asymptote and like doesn't look like it on our graph, right? Because it is not a vertical asymptote. I'm actually going to cross off x equals -2 is not a vertical asymptote. Gotcha.
Got it.
But I'm going to teach you why it's not, and we're going to make sure we watch out for this, okay? So when we have something like this, it's still a discontinuity. If you plug in your calculator -2 after you graph this, with trace, it will still give you undefined. So it's not an asymptote. What it is a little bitty hole, a little bitty graph. So the line's going, and then it stops briefly because -2 would give us 0 on the bottom, right? And then it keeps going. It just isn't infinite discontinuity. It's not doing this on either side. It's just stopping for 1 second. It's a little hole, okay? So we're going to, either you could graph it and you could see that, but you're not going to always have your calculator, so we're going to learn right now from our equation, how do I tell when that's going to happen, okay? All right, so for now, cross off -2 and write that actually there's a hole at -2, x equals -2, and then let's flip the page and figure out when this happens, what our rule is going to be for holes, okay? Flip. Okay, for us to have a hole in our graph, this is what has to happen. We have to have a numerator and denominator that have common factors. When we have our numerator and denominator having common factors, it's kind of like that factor cancels out, and so that value is no longer an asymptote, it's actually a hole. Okay, when the numerator and denominator have common factors, we're going to have a hole, and another word for that we learned in Unit 1 is we called that, remember, a removable discontinuity, if it had one little spot missing. If not, go back and look at your 3 types of discontinuity. Hole is removable, so those are kind of like synonyms. If I ask for any removable discontinuities, I'm asking for any holes in your problem, okay? Okay, so let's talk about when that happens. It says that that's going to happen when you have a common factor on the top and the bottom. So we factored the bottom, right?
Yep.
And we had like x minus 4, x plus 2 or something, right? You remember that? On the previous example, I think that's what we had. X minus 4 and x plus 2. Okay. We didn't take the time though to factor the top. We just like looked at the bottom and we wrote down our zeros. What we are going to add on now with holes is we actually really need to factor the bottom and the top, because if there is a common factor, if there was a x plus 2 on the top, then these would have canceled, and that x equals -2 that we thought was an asymptote is actually a hole in our graph. Okay? So whenever our factor matches a factor on the top, that is actually a hole, not a vertical asymptote. Okay, so let's factor this one and check. I'm going to give you this example, and I think once you see an example, you'll feel a little bit better. Okay? We have a polynomial here. Let's do horizontal first, because that's safe. Okay? Horizontal asymptote. Bigger on bottom, bigger on top, where exponents are the same. I heard someone say that they're the same. So we're dividing. 1 divided by 1 is 1. Okay. Now when we get to our vertical asymptotes, we have to be careful, because we would factor the bottom, but if it has a common factor at the top, it's actually not a vertical asymptote. So what we're actually going to do is we're going to factor the top and we're going to factor the bottom. So that y'all don't have as much work, we're going to split us down the middle. Okay? If you are Martin and Juan Carlos over this way, I want y'all to factor the top. Top people. Okay. If you're over here, and we've got Edith all the way, Diego, all these people, factor the bottom for us. Okay? Go. Do your box factor to speed us along. Write it bigger. Okay, tell people, raise your hand once you have it so I can steal your work. Lirio, what'd you get?
X plus 4 and 6 plus, x plus 6.
Cool. Okay, any bottom people got it?
X
Do
minus
yourself.
3, x plus 1.
Okay. Finish up your factoring, but then you can go ahead and kind of steal these answers from your neighbor. These neighbors over here, the top people, should have gotten their factors, so I'm just going to rewrite my polynomial, but factored. Okay? On the top now I have x plus 4 and x plus 6, right? Okay. On the bottom people, we had x plus 4 and x minus 3. So now I have the bottom and the top factored, okay? You would technically do 2 box methods if that's what you were doing, but we're just kind of moving along. Okay, so when we get to our vertical asymptotes, it would be very tempting to go and write x equals negative 4 and x equals 3, right? But raise your hand if you notice something based off of what we just talked about that's going on here that's special. Lazaro? X plus 4 is a common factor that we could cancel. Therefore, what's the only vertical asymptote? X equals 3 is the only one that we actually are going to keep. Okay? And we're going to say that x equals negative 4 is actually what we call what? A hole or a removable discontinuity. Okay? So we just are clarifying now that those are not both vertical asymptotes. One's a hole and one's a vertical asymptote. Okay? For your domain, both of these are still going to be excluded from your domain. So just because this is a hole doesn't mean it's like good to go. Like it still gives us 0 on the bottom. It's still a discontinuity. So your domain is still going to be stopping at negative 4 and stopping at 3 like we saw with our vertical asymptotes when we had 2. Okay? Cool? Alright. We've got a couple minutes left, so I want you to internalize all this by really quickly taking a look at the next one and knocking out as much as you can. As you do that, I'm going to kind of start raffling off so that I can let you out on time. So kind of start checking, making sure you don't have any questions for me. And I'm going to see who our raffle winners are. I got that? Feel okay about it? Okay, first winner today is going to be 462.II.Holes.
So close.
Ehong, which color do you want? Blue. Blue. Okay, you get your favorite snack next week, so you just need to let me know your order. It could be a drink, Dr. Pepper, could be candy, could be chips, I don't know. You think about it, I'm going to write it down, okay? Alright, next person. 462.060. Brandon, what color do you want?
Yellow.
Ooh, 3 emoji erasers for you. Not just 1, but 3. Okay, here we go. And last but not least, this is a good one. 462.051. Kennedy gets an automatic 10 on the next problem set. Alright, bye-bye. Brandon, don't forget your erasers. Here you go.
What is that?